Dear student, today we will discuss about a very important concept in computer science that was a breakthrough in computer science known as the concept of stored program. Before starting the actual concept of stored program, we must see the problem before we were able to store the programs into the random access memory or the main memory. So previously, whatever computer was built by scientists, the algorithm was put within the CPU. So for example, we have learned about this algorithm in our previous module that adds two numbers, and if the previous or the initial computers have such an algorithm that was built in within the CPU. So this means that only one computer that was built by a scientist could only perform addition. So if we want to subtract numbers, we need another computer. If we want to multiply numbers, we need another computer, because we do not save that program somewhere in the computer. However, it was stored within the central processing unit. So then there was a next generation that was rewiring of the CPU. So whatever CPU we have built, so that was calculating actually previously for the addition. Now we rewire that CPU and that is now going to perform subtraction. But still the problem is there that we were not able to make such a computer that could perform multiple things as the computer of today. So a breakthrough of storing the program in main memory that is incorrectly credited only to John von Neumann. So that was the concept where different people were working in the world, and there are a lot of information in your book that which groups were actually working to store the programs in the main memory. So let's see that we have such a CPU which we have learned in the previous lecture. So what we will do, that we will store the program here in the main memory. So you know that main memory has address. So for example 0, 1, 2, 3, 4, 5. So you learned that our previous algorithm of addition of two numbers have only 5 steps. So first step would be stored here, the instruction that what to perform. The second instruction of that algorithm will be stored here, third here, fourth and fifth. So all of the instructions have been stored in the main memory, and then it is the requirement then that these instructions are fetched using bus to the central processing unit, and then there are some special purpose registers which hold such a machine instruction here. So machine instruction is here, and that machine instruction is being decoded to understand what actually is the meaning and what actually this program want to do. So the first instruction was to get the data from RAM. So data would be somewhere here, for example at this position of 100. So this instruction will fetch this data to one of the register, and so on. So this means rather only storing only the information in the main memory, we are also going to store the machine instructions or the algorithmic step that what need to be performed in this program. So today we have discussed that previously computers were made having dedicated CPUs, and those dedicated CPUs have only one task which they can perform. However, after that there was an era of rewiring of the CPU, and then there was an era which is the current era, that is the stored program era, that we can store the program within the RAM, and then we can decode those instructions to see what actually this computer should do. So this is a generic computer which can perform multiple tasks based on the instructions which we have written and stored in the RAM, and decoding of those instructions by the central processing unit.